Okay children, now we are going to again, these are the things that we have learned so far. Comparison of fractions having the numerator as 1. The larger fraction is the fraction with the smaller denominator. The larger fraction is the fraction with the smaller denominator. It means if we want to find the larger fraction, so we have to find the smaller denominator. When we comparing 1 out of 3 and 1 out of 5, 3 and 5 are the denominators. So to get a larger fraction, we have to get the smaller denominator. 3 is the smaller denominator. So we can draw the symbol like this, because 1 out of 3 is the larger fraction. Okay. Now next exercise. Next example. 1 out of 8 and 1 out of 6. Now when we comparing these two fractions, 8 and 6 are the denominators. 8 and 6 are the denominators. 6 is the smaller one. So you want to find the smaller denominator. No? So 1 out of 6 is the larger fraction. So we want to draw the symbol like this. Okay, now comparison of fractions having the same numerators. The larger fraction is the fraction with the smaller denominator. Now if you want to find the larger fraction in here, you want to find the small denominator. It means you have to use the same method we use in this first one. So 2 out of 7 and 2 out of 9. 2 out of 7 and 2 out of 9. 7 and 9 are the denominators. So 7 is the smaller one. So 2 out of 7 is the larger fraction. Why? Because the larger fraction is the fraction with smaller denominator. So we can draw this symbol. It means opposite side must show the bigger one. Okay. Next, 2 out of 5 and 2 out of 3. What are the denominators? 5 and 3. Okay, then 3 is smaller than 5. Again, look at this. The larger fraction is the fraction with a smaller denominator. It means 3 is the smaller one. So this is the larger fraction. So we can draw the symbol like this. Okay, now third one. Comparison of fractions having the same denominators. Comparison of fractions having the same denominators. The larger fraction is the fraction with the larger numerator. The larger fraction is the fraction with the larger numerator. Now children, both the fractions have same denominators. So now you want to think about the numerator. Larger numerator gives the larger fraction. It means 6 is bigger than 5. So 6 out of 8 is the larger fraction. After that, 8 out of 9 and 3 out of 9. Same denominators. Now you want to think about the numerator. 8 is the bigger one. So this is 8 out of 9 is the larger fraction. Now you can draw like this. Okay, now more on comparisons of fractions. It means in here we are going to talk about the fraction with different denominators. The fraction with different denominators and different numerators. Okay. Now look at this example. Now we are going to compare 1 out of 2 and 2 out of 5. We are going to compare 1 out of 2 and 2 out of 5. Now tell me, how can we compare those things? How can we compare these two fractions? Do you have any idea for that? Now earlier we have discussed about those things, no? So now we are that 2 different denominators and 2 different numerators. So how can we compare this type of fractions? Okay, now my children, we have earlier learnt about equivalent fractions. Okay, we have learned about equivalent fractions. Now we are going to find the common denominator. Now we are going to find the common denominator and then we can compare these two easily. Okay. Now 2 and 5. This 2 and 5. Now we are going to write an equivalent fraction. It means that two fractions must be same to each other. Then when the denominator are equal, very easily we can compare them. No? So for that we want to find the LCM of 2 and 5. Okay, if we find the LCM of 2 and 5, we can get a common denominator. So very easily we can compare them. Okay, now we are going to find LCM of M of 2 and 5. LCM of 2 and 5. I think already you have learned those things. To find the LCM, you can write the multiples of 2 and 5. 2, 4, 6, 8, 10, 12. Like that. After that, 5, 10, 15, 20, 25. Like that. No. After that, what is the common number? What is the common number to 2 and 5? What is the common number to both the numbers? 10. 10 is the common lowest number. LCM in lowest common number. No? So 10 is the lowest common number. Lowest common multiple. Okay, so LCM of 2 and 5 is 10. What is LCM of 2 and 5? 10. LCM of 2 and 5 is 10. It means, children, now you want to convert this denominator as 10. This 5 want to convert as 10. Okay. Now 1 out of 2. 1 out of 2. This 2 we need to convert into 10. So, how can we convert this 2 into 10? Okay, we need to multiply this 2 by 5. Okay, to get 10, we need to multiply this 2 by 5. Okay, I told you earlier, if you do something to denominator, numerator also want to do the same thing. It means this 1 want to multiply by 5. Okay, children, this 1 need to multiply by 5. So, 5 out of 10 is an equivalent fraction to 1 out of 2. Okay, children. Now, this 2 out of 5. Now, this 5 I need to convert into 10. This 5 I need to convert into 10. How can I convert 5 into 10? I need to multiply this 5 by 2. I want to multiply this 5 by 2. Okay. Now, if I do something to numerator, denominator, if we do something to denominator, numerator also want to do the same thing. It means this numerator also want to multiply by 2. So, 2 times 2, 2 times 2, 4. 2 times 2, 4. Okay. Now, you can compare these two fractions. 5 out of 10 and 4 out of 10. Now, both the fraction we convert into same denominator. Now, we can compare that two together. 5 out of 10 and 4 out of 10. Okay. Now, earlier we couldn't compare because both the fraction didn't have any common number and numerators also different to each other. So, at that time we want to get the common denominator. Now, we got the common denominator. Now, very easily we can compare that too. If they have the common denominator, we have to compare the numerators. The larger numerator gives the larger fraction. It means 5 out of 10 is the larger fraction. According to that, 5 out of 10 is equivalent to 1 out of 2. It means what is the larger fraction in here? 1 out of 2. 1 out of 2 is the larger fraction. Are you clear, children? Okay, now I am going to get another example. 3 out of 2 and 9 out of 8. 3 out of 2 and 9 out of 8. Okay, now children, 3 and 9. Okay, when you comparing 3 and 9, this 3 we can convert into 9. No, so we no need to change this thing. No. So if we change this fraction, very easily we can compare those two fractions together. Okay, now how can we convert this 3 into 9? How can we convert this 3 into 9? How many 3's in 9? There are 3 3's in 9. So these 3 want to multiply by 3 to get 9. Okay, 3 times 3, 9. And if we do something to denominator, numerator also want to do the same thing. So 2 times 3, because these 2 also want to multiply by 3. No? So 2 times 3 means 6. Okay, 3 times 3, 9. 2 times 3, 6. Okay, so this 6 out of 9 means it's equivalent fraction to 2 out of 3. Now very easily we can compare these two fraction. Instead of 2 out of 3, we can write 6 out of 9 and 9 out of 8. Now children, both the fraction have the common denominator. So you want to think about the numerator. Larger numerator gives the larger fraction. It means 8 out of 9 is the larger fraction. Okay, when we compare these two, it means 8 out of 9 is the larger fraction. You want to draw like this. Okay, now addition and subtraction of fractions. Addition and subtractions of fractions. Now children, now we are going to add and subtract fractions. Now first we are going to talk about addition of fractions with having same denominators. First I am going to teach you about addition of fractions having same denominators. Addition of fractions having same denominators. Okay, now your mother bought a cake and she divided it into 8 parts. She divided it into 8 parts. Okay, and she gave you one piece of cake. She gave a piece of cake for you. Okay, how can you write that one as a fraction? 8 parts are there and you take 1 part. So we can write as 1 out of 8. After that, your mother gave 2 parts for your 2 sisters. Your mother gave 2 parts for your 2 sisters. So we can color like that. So now you want to find the total pieces that you have taken from the cake. Okay, so it means you want to add your piece with your sisters, with the sisters pieces. Okay, now this is your piece and this is the piece that your sisters have taken. Okay, so Now we want to add these two together to get the answer. To get the total, we have to add these two together. Okay. Now, how can we add these two together? It means, are we adding these two together and these two together? No. Okay. When you add these fraction, now they both the fraction have same denominator. No. So for the answer, you want to get you want to get one denominator. You want to get the same denominator for the answer, because both the fraction have same thing, so same denominators. So for the answer also you want to get that denominator. It means 8. After that you want to add this 1 and 2 together. What is the answer? 1 plus 2. You want to add this 1 and 2 together, no? So 1 plus 2 means 3. The answer is 3 out of 8. Okay children, now we are going to learn about addition and subtraction of fractions. Under that, first we are going to talk about addition of fractions having same denominator. First we are going to talk about addition of fractions having same denominators. Okay, now for that I will take some example for that. Now you imagine like this. Your mother bought a cake and she divided it into 8 parts. She divided it into 8 parts. Okay children? Okay. And she gave one part. She gave one part for you. How many parts? One part for you. Okay. And after that, your sister came and she asked 2 parts. She asked 2 parts from it. How many parts? 2 parts. This part for your sister. After that we want to find the total amount. Total amount of parts you and your sister have taken from that whole one. Okay. Now children, the part you received we can write as 1 out of 8. The part you received is 1 out of 8. What is the part your sister received? Your sister received part is 2 out of 8. Okay. Now to find the total amount we have to add these two together. Okay. And children, if now see both that the denominators are same. If there are the same denominators, we can add them together. For the answer you want to get, you no need to change the denominator. You want to get 8 as a denominator, but you have to add the numerators together. You no need to change the denominators. You are not adding 8 plus 8, 16. Instead of both the denominators, you have to take one number, and after that numerators you have to add together. It means simply I can explain like this. If they are given same denominator, you have to add only the numerators together. Very easily you can get the answer. So 8 is the denominator and you have to add the numerator together. 1 plus 2. Okay children. Now 8 is the denominator, no need to change it. So 1 plus 2. You have to add 1 and 2 together. What is the answer? 3. The answer is 3 out of 8. Are you clear? Now when you add these two fractions, you can get 3 out of 8 as the answer. I think it's very clear for you. Now I will take some examples. 2 out of 9 and 5 out of 9. Now we are going to add these two together. So both the fractions have same denominator. So you have to add only the numerators together. You have to put 9 here, and after that you have to add the numerators together. 2 plus 5. What is the answer? 2 plus 5, 7. Then what is the answer? 7 out of 9. Is this difficult? No, it's very easy for you. Okay, I'll take another example. This is example, first example, now the second one. Okay, now 3 out of 11 and 5 out of 11. 3 out of 11 and 5 out of 11. When we add these like this thing, first you want to see same denominators are there. So what can you do? You can add the numerators together. You have to put denominator here and 3 plus 5. 3 plus 5. What is the answer for 3 plus 5? 8. 3 plus 5, 8. You cannot change 11. The answer is 8 out of 11. I think you are very clear about this addition of fractions having same denominators. Okay. Subtractions of fractions having same denominators. Now earlier we have added the fractions. Now we are going to subtract. Now for example, now look at these fractions. 2 out of 3 subtract 1 out of 3. Now when we adding them, what did we do? It means if the denominators are same, we can add the numerators together. No? So the likewise when we subtract also, if there are the same denominators, we can subtract the numerators. It means you have to put the denominator and you want to subtract. You can subtract the numerators. It means you want to subtract 1 from 2. What is the answer then? 1. The answer is 1 out of 3 or 1/3. Okay. Next example. 9 out of 7 subtract. Okay. 7 out of 9 subtract 3 out of 9. 7 out of 9 subtract 3 out of 9. Okay, now both the fraction have the common denominator. So you have to subtract. You have to write 9 as the denominator. You cannot change it. And after that you want to subtract numerators. It means you want to subtract 3 from 7. You want to subtract 3 from 7. Okay, so 9 you cannot change the denominator. So you want to subtract 3 from 7. No? So the answer is, what is the answer? 4. The answer is 4. So how can you read this fraction? 4 out of 9. You can read this fraction as 4 out of 9. Okay children, now you know how to subtraction of fractions having same denominator and addition of fraction having same denominators. Okay. Now after that we are going to addition and subtraction of fractions having different denominators. Okay, now get ready for that. Okay, more on addition of fractions. Earlier we have solved them because when we add there was a same denominators. Now more on it means now there are different denominators. Now we are going to learn how to add that type of fractions together. 2 out of 1 plus 3 out of 1. Now look at these fractions. 1 out of 2 and 1 out of 3. So how can we add these two type of fractions? How can we add these two fractions together? Now earlier we used there were same denominators. No? So now they have two different denominators. So what do we want to do for there? Okay, now first we want to get the same denominator. It means we want to find the LCM of 2 and 3. Okay. You want to find LCM of 2 and 3. I think already we have done earlier also, but again I will do it. Now I will use this method to find the LCM, lowest common multiple. Here first we want to divide by 2. How many 2's into 1? Here we cannot divide 3 by 2, so we want to put 3. After that, we want to divide this number by 3. Prime factors. Okay, we want to divide these using with the prime factors. So no need to divide 1. 3 divide 3 mean 1. After that, when you multiply these two together, you can get the LCM. Okay, so what is the LCM of 2 and 3? It means you want to multiply 2 and 3 together. What is the LCM? 6. Okay children, 6 is the LCM. Okay, it means this 2 also, you want to convert this 2 into 6 and this 3 into 6. This both the numbers you want to convert into 6. Okay, now we want to write them separately like this. Now you want to convert this 2 into 6. It means, look at this. Now this 2 into 6 means you have multiplied by 3. It means this 2 want to multiply by 3. You want to multiply this 2 by 3. Now, if you do something to denominator, numerator also want to do the same thing. It means this 1 want to multiply by 3. Are you clear children? This 1 want to multiply by 3. Okay, next. Now we want to convert this 3 into 6. So, now look at this. If I close this 3 to make 6, if I divide 6 by 3, what is the answer? 2. It means this 3 want to multiply by 2 to get 6. Okay, it means now I have to multiply this 3 by 2. Okay, I have to multiply this 3 by 2 to get 6. Now if we do something to denominator, numerator also want to do the same thing. It means this 1 also want to multiply by 2. 1 also want to multiply by 2. Now 2 times 3, 6. No, 2 times 3, 6. 1 times 3, 2 times 3, 6. And then you want to multiply the numerators. 1 times 3, 3. Okay. After that, add 2 times 3 times 2. What is the answer? 3 times 2, 6. 1 times 2, 2. Now look at this. Now we have same denominators. So if there are same denominators, we can add the numerators together. So 6, we have write denominator, and after that you want to add the numerators together. 3 plus 2. What is the answer then? 5 out of 6. What is the answer children? 5 out of 6 is the answer. Are you clear? Okay. Now move on subtractions of fractions. Earlier we have subtracted the numbers with the same denominators. Now if they are given fractions to subtract with different denominators, how can we do that? For example, 1 out of 2 subtract 6 out of 1. Now look at this. 1 out of 2 subtract 1 out of 6. Okay. Now how can we subtract this? Do you have any idea about that? Okay. Now 2 and 6. Can you see these two numbers? 2 and 6. So first you want to find the LCM of 2 and 6. Why do you want to find LCM of 2 and 6? Because if you can get same denominators, very easily you can subtract the numerators. Okay. So now we are going to find LCM of 2 and 6. LCM of 2 and 6. It means now we can use the division method for that. 2 and 6. Okay, 2 is the lowest prime factor. First want to divide by 2. 2 divide 2, 1. And after that you want to divide this 6 by 2. You can divide this 6 by 2, no? So the answer is 3. After that you cannot use 2 because you cannot divide 3 by 2, no? So you want to use 3. How many 3's in 3? 1. After that, when you multiply these two together, you can get the LCM of 2 and 6. Okay children. 2 times 3 mean what? 6. It means, do you want to change this number? No need, because 6 is there, no? So you want to convert this 2 into 6. So very easily you can subtract those things. Okay. Now how can you convert this 2 into 6? How can you convert this 2 into 6? Want to? Now look at this 6. You want to make 6, no? Now if you close this 2, you can see this 3. It means you want to multiply this 2 by 3 to get the answer. And if you do something to the denominator, numerator also want to do the same thing. Okay, and subtract mark. You don't need to change this because already 6 is there. 2 times 3, 6. 1 times 3, 3. Okay, now the answer is 3 out of 6. Now you can subtract 1 out of 6 from this 3 out of 6. Okay, now both the fractions have same denominator, so you can put 6 and after that you can subtract the numerators. 1 want to subtract from 3. So what is the answer? 2 and 6. So we can call this one as 2 out of 6. Okay children, are you clear? Okay, now I'll give some examples. Okay, now 8 subtract 2. Okay, now you just imagine about this thing. Can you solve this thing? Is this difficult? No. So first you want to find the LCM of 8 and 9. Okay. LCM of 8 and 9. Okay. It means you want to find it, no? So first 2. Want to divide by 2. 4 and 9. Again you can divide by 2. How many 2's in 4? 2. 9. Because we cannot divide 9 by 2, no, so you have to put it. Again we can divide 2 by 2. So 1, now 9. After that, what is the next prime factor? 3. We can use 3. How many 3's in 9? 3. Again we can divide this one by 3. Okay. Now until we are getting 1, we have to divide the numbers from prime factors. Now after that we want to multiply these things together to get the answer. 2 times 2, 4. 2 times 2, 4. 4 times 2, 8. 8 times 3, 24. 24 times 3, 72. Okay children, now look at this. 24 times 3. 3 times 4, 12. 1 remaining. 3 times 2, 6 and 1, 7. The answer is 72. Are you clear? Okay. Now, then you want to convert this 8 into 72 and you want to convert this 8 into 72 and 9 also want to convert into 70. Okay. So, how many 8's in 72? How many 8's in 72? There are 9 8's. If we find the 8's in 72 means there are 9 8's. Like this, how many 9's in 72? There are 8 9's. Okay, it means this 8 want to multiply by 9. Okay children, this 8 want to multiply by 9 and this 3 also want to multiply by 9. It's a rule. Okay, if you do something to denominator, numerator also want to do the same thing. After that, 1 out of 9. Now to convert this one into 72, you want to multiply by 8. This 9 want to multiply by 8 means this one also want to multiply by 8. Okay, 8 times 9, 72. 3 times 9, 27. 9 times 8, 72. 1 times 8, 8. Okay, now 72, won't write down, 27 you have to write up, subtract 8 and 72. What do you want to do now? Same denominators. So, now you can subtract the numerators. Okay, now you want to subtract 8 from 27. 8 from 27 mean what is the answer? 19. 72 you cannot change, no. So what is the answer? 19 out of 72. Okay, now we are going to learn about a fraction of a homogeneous collection. Now can you see how many balls are there? 5 balls. A collection of 5 balls take as a unit. Now we can take this 5 ball as a 1 unit. Now we have to remove 2 balls from it. We have to remove 2 balls from it. We want to find the amount of remaining balls. Earlier there were 5 balls, no, and we removed 2 balls. It means now it has 3 balls. So how can we write the amount of remaining balls? 3 out of 5. Okay children, I think now you are very clear about this part also. Okay children, now I think you are very clear about the fraction lesson. Now I need to check your knowledge, okay, so that you can download the question paper from our website. Okay, now we are going to discuss these questions. Okay, test under the fraction lesson. Underline the proper fraction and circle the unit fraction. You want to underline the proper fraction and you have to circle the unit fractions. Okay, now I am going to discuss about those things. Now look at this fraction. How can we read this fraction? 7 out of 2. 7 out of 2. How can we read this fraction? 2 out of 7. 2 out of 7. This one. 1 out of 9. 1 out of 9. What about this one? 4 out of 7. 4 out of 7. This one. 1 out of 25. 1 out of 25. Last one. 1 out of 2. 1 out of 2. Okay. Now we are very clear about those things, no? Now when we talk about this fraction, now you know fraction has 2 parts, denominator and the numerator. Okay, denominator and the numerator. When we talk about the proper fraction, what is the thing that you have learned in there? When you talk about the proper fraction, denominator is bigger than numerator. Now you want to compare these two. 7, 2. Now in here, denominator is smaller than. So can you take this one as a proper fraction? No, this is not a proper fraction. Can you take this one as a unit fraction? No. Why? Because if you talk about the unit fraction, numerator must be 1. So this is not a proper fraction. This is not an unit fraction. Okay, now this one. 2 out of 7. Denominator, numerator. No, denominator is bigger than numerator. So we can take this one as a proper fraction. So we have to underline it. I have underlined. Okay, next. 1 out of 9. So numerator. Now what is the numerator? 1. It means it must be a unit fraction. We have to circle it. And after that, I told you, when you talk about the proper fraction, numerator is smaller than denominator. It means here denominator is bigger than numerator. So we have to underline this. Why? Because this 1 out of 9 means it's a unit fraction and it's a proper fraction also. Are you clear, children? Okay. Then next one. 4 out of 7. Now here 7 is bigger than 4. 7 is bigger than 4. So we can take this one as a proper fraction. So we have to underline it. Are you clear, children? Okay. Next. 1 out of 25. Numerator is 1. So it means this is a unit fraction. And denominator is bigger than numerator, and this is a proper fraction also. It means now you know all the unit fractions we can take as proper fraction. Now if we take about this proper fraction, are all the proper fraction are unit fraction? No. All the unit fractions are proper fraction, but all the proper fractions are not unit fractions. You want to keep this in your mind now. All the unit fractions are we can take as proper fractions. Okay, now this one. 1 out of 2. Okay, now numerator is 1. It means this is an unit fraction, and in the other way 2 denominator is bigger than numerator, so this is a proper fraction also. Are you clear, children? Okay. Now I think you are very clear about this proper and unit fractions. Okay. Now second question. Compare the fractions using with these symbols. Okay. We have to use these symbols to compare those fractions. First one. Now here same numerators. You want to think about the denominators. If there are same numerators, you have to think about denominators. No, it means smaller denominator gives the bigger fraction. Small denominator gives the larger fraction. It means 1 out of 2 is the larger fraction. Okay, it means open side must, you have that 1 out of 2 is the bigger one. Okay, so you have to put the symbol like that. It means this open side shows the bigger fraction. Are you clear? Okay. Next one. 3 out of 8 and 3 out of 5. In here also the same thing. No, same numerator. So you want to get the smaller denominator to find the larger fraction. It means 5 is the smaller one. So this is the larger fraction. Okay. Next, third one. Same denominators. If the same denominators, how can we find the larger factor? How can you find the larger fraction? So that you want to get the larger numerator. Bigger numerator gives the larger fraction. So when we comparing 4 and 7, 7 is the larger number. So this is the larger fraction. Okay, children. Next. Now this one. 1 out of 6 and 2 out of 3. Now this is little bit, but this is not like this thing. No, so we have to solve this. No, it means we want to get a common denominator to solve that. Okay. How can we solve it? Now for this 3. No, this 3 also want to convert as 6. No, because 3 is a multiple of 6. No, so very easily we can convert this 3 into 6 by multiplying 2. Okay, children. Now it means 6 out of 4. Are you clear? Now you want to comparing 1 out of 6 and 4 out of 6. So what is the larger one? 2 out of 3 is larger than 1 out of 6. So this is the larger fraction. Okay. Now 3 out of 4 and 1 out of 3. Now how can we compare these two numbers? You want to find the LCM of 4 and 3. What is the LCM of 4 and 3? 12. It means this 4 want to multiply by 3 to get 12. It means this 3 also want to multiply by 3. Okay. And this 3 want to convert to 12 mean you want to multiply by 4. No? So this 1 also want to multiply by 4. Here answer, what is the answer? 12. 12 out of 4 and 1 out of 3. Now how can we compare these two numbers? You want to find the LCM of 4 and 3. What is the LCM of 4 and 3? 12. It means this 4 want to multiply by 3 to get 12. It means this 3 also want to multiply by 4. Okay. And this 3 want to convert to 12 mean you want to multiply by 4. No? So this 1 also want to multiply by 4. Here answer, what is the answer? 9 out of 12 here, 4 out of 12. No, it means 3 out of 4 is the larger part, larger fraction. So we want to put the symbol like this. Are you clear, children? Okay. I think now we are very clear about comparing fractions and finding proper and unit fractions. Okay, children. Now you can do all the exercises and then you can download the answers from our website. So you have to practice it more and more, and I think you learn lot of things about this fraction lesson.